Hi all of you. In second year organic chemistry, SN1, SN2 reactions are very important for all types of competitive examinations. SN1 reactions and SN2 reactions. SN2 reactions order is highest is 1 degree alkyl halides, then 2 degree alkyl halides, then 3 degree. That is the order of SN2 mechanism in alkyl halides. In the same way, SN1 also opposite direction. It is very highest in 3 degree, then 2 degree, then 1 degree. That is the order of the reactivity of the alkyl halides in the substitution reactions, nucleophilic substitution reactions. Now, let us learn for competitive examination point of view, most important concept relating to these reactions, substitution reactions. For example, some nucleophiles, generally we take nucleophile, we have practiced example with OH minus, it is a nucleophile. O hydroxyl group is a nucleophile. It is a nucleus loving group. Nucleus loving group means positive charge loving groups are called nucleophiles. So OH we have taken and practiced some examples also. Now, some other nucleophiles are there, they act as both, means two atoms they contain. Example, some important nucleophiles are there like cyanide and nitro groups. Cyanide group and nitro groups, these two are very important for competitive. Why? Because in these nucleophiles there are two atoms are there, both act as a nucleophile. Both carbon acts as a nucleophile, nitrogen also acts as a nucleophile. Here also nitrogen acts as a nucleophile, oxygen also acts as a nucleophile. Then such a type of nucleophiles are called ambident nucleophiles. Ambident nucleophiles. So this is a very important concept because specifically we are taking two nucleophiles in which both the atoms act as a nucleophile. Then which atom prefer, that we are going to learn now. For example, you take this nitrile group, cyanide or CN group. In this, it has two contributing structures, means resonance structures, or another name is canonical forms. Our cyanide group has two canonical forms. What are the two canonical forms? Sometimes carbon gets negative charge, and this is cyanide group. It has another contributing structure. Carbon has 2 electrons, here 2 bonds, nitrogen gets a negative charge. So these are the two contributing structures of this group, cyanide group. In this position, carbon atom acts as a nucleophile. In this contributing structure, nitrogen acts as, which has negative charge, it acts as a nucleophile. So this group is called the ambident. There are two scopes are there. Okay, let us see now. Well, two different products are also possible. For example, if this attacks in the nucleophile substitution reaction, we get for example, what is alkyl? Alkyl halides undergoes this substitution. Alkyl group means R group, X, some halogen. So X is substituted by here. If a carbon substitutes, what happens? We get RCN. It is alkyl cyanide. Its name is alkyl cyanide. Alkyl cyanide. When carbon attacks carbon breaks the carbon attacks this R group, alkyl group, our halogen goes out. Substitution reaction takes place. Yes. Here RX bond is there, here RC bond is there. So this is called alkyl cyanide. So it depends upon the name of this alkyl group only, product name depends. Here when nitrogen attacks, in this resonance structure, nitrogen attacks RX plus C. Here C is a negative charge, in this here nitrogen is a negative charge. So nitrogen attacks, then what is the product? RNC. This is alkyl isocyanide. Alkyl isocyanide. alkyl isocyanate. So different products, their properties are different. So such a type of these are called ambident nucleophiles. There are two choices for the nucleophile to attack in a species, chemical species. Now when you come to this NO2 nitro group, nitrite, its name is the nitrite group. So also we get two products. In this nitro group also gives two products. Let us see what are the two products. Now take again nitro group. Nitro group structure is NO2, structure is ONO. So here nitrogen has a lone pair. Yes, nitro NO2 minus. Yes, O can attack the R group, N can attack the means that is this also ambident nucleophile. Ambident nucleophile. Let us see its reaction. Let us see its reaction. For example, again take alkyl halide. Alkyl halide. Then take this NO2 group. Then what happens? Product N can attack R group or O can. Yes, if O attacks, we get what? That is RONO. X come out as a negative. Here also other product is X minus. X minus. Here also X minus. Here oxygen is attacked. Then what is the product name? Nitrite. Alkyl nitrite. Alkyl nitrite. So very important nomenclature. Itself it is an IUPAC nomenclature, common name also. Both are the same. Alkyl nitrite. Be very confident of the name of this product. When NO2 group attacks RX, alkyl halide, we get alkyl nitrite, TRITE. Now same NO2 group, in NO2 group N attacks the R group, alkyl group. Let us see that. Yes, again RX, alkyl halide is there, alkyl halide is there. Again NO2, N attacks the R group, X goes out. Here X goes out, oxygen attacks, oxygen is attacking. So as a result we get RNO2. This is called nitroalkane. Name is alkyl nitrate. This is alkyl nitrite. This is nitroalkane. Nitroalkane. Yes. Products are different. So everybody should know this point. Let us see based on this one more reaction with cyanide with alkyl halides. Okay, this is about ambident chemical reactivity with alkyl halides. Now let us take two compounds, Na or KCN. This is also important for a competitive examination point of view. Kc and AgCN, potassium cyanide and silver cyanide. Two compounds are there. These two compounds react differently with Rx. Why? Let us see. For example, you know that this is a ionic compound, this is a covalent compound. More ionic. This is the bond between Ag and carbon is a covalent type. It does not break, strong bond. Ion bond is very weak. When it is dissolved in an electrolyte or water, it splits into ions. So this is ionic, most important point. Ion compound, this is a covalent. These separately dissolved separately in two containers. Then Rx is added. When Rx is added to that, what is that? KCN, it produces K plus and Cn minus ions. Since it is ion compound, it produces oppositely charged ions. Now, you know very well, this is negative, partial negative, partial positive. So our cyanide attacks this carbon. Carbon is free. Here, carbon is free. Here, potassium ions are there, cyanide ions are there, aqueous. Carbon is free, not bonded to potassium. Carbon is free. So, nitrogen also free. Nitrogen also free in this. Carbon is free, nitrogen is free because nothing is there. Potassium is in the form of ions in the solution. So, which acts as a nucleophile here? Which is a better Carbon only attacks, even there is a chance for nitrogen, it does not attack. Reason, if carbon attacks, we get RCN, alkyl cyanide will get. If nitrogen attacks, but it does not attack, if nitrogen attacks, we get NC, isocyanide we get. But this is this RC bond, R means alkyl group, carbon is there, CC bond, here CN bond, in this CN bond, this is a non-polar bond, strong, non-polar is bond is strong and stable, this is a polar bond, unstable, this is the reason this only takes place. Means cyanides only formed, isocyanides do not form. Reason is CC bond is stronger than CN bond. It is a polar, this is non-polar, polar. Polar bond is, the bonds are weaker, we know. Non-polar bonds are stronger. So stable bonds only form cyanides. When it comes silver cyanide, let us talk about silver cyanide. Silver cyanide. When RX is added with the aqueous solution of RX is alkyl halide is mixed with AgCN, it does not give ions. Carbon is not free, nitrogen only free. Here nitrogen only free. So nitrogen only attacks carbon atom, X goes out, leaving group. Then we get RNC isocyanide. So in the examination, he will give this type of questions. What is the product? Since it is not ionic, covalent nature, nitrogen only free, carbon is not free. If carbon is free, means it only attacks the nucleophilic center of alkyl group. So we get here isocyanides only. These two are also very, very, very important for competitive examination point of view. Thank you very much.